All right, guys, chapter 8. Two sections, so these are getting not to be that long of sections. So if we're staying on top of things, they shouldn't take us that long, but the ideas are getting a little tougher. Here's one I like. It's talking about gestation. I think these are great questions and we can relate to them. It says, suppose the length of pregnancies of a certain animal are approximately normally distributed with mean 235 and a standard deviation of 21. So on this first problem, find the probability that a randomly selected pregnancy, so this is one, lasts less than 227 days. So this is the stuff that we were doing in chapter 7 with our normal distribution. So exact same question as before. We're going to go to stat, calculator, normal. Up comes this awesome thing. So we got a mean of 235, a standard deviation of 21. 235, 21. So we got 235, standard deviation of 21. And then they want to know less than 227. Less than 227. And there I go. Like, that's my answer. That's what we did in chapter 7. So 0.3516. 3516. Good. That's what we got previously. Now we have a sample. So here's where the chapter 8 ideas come in. We have 11 pregnancies, right? So what we're going to have to change here is our standard deviation. Our standard deviation is going to change. They talk about in section 1 that standard deviation or standard error of the mean is the mean divided by the square root of n. So if we look at, let's get rid of that stuff. If we look at our mean, let me find the question again. Our mean's 227, but we had 11 pregnancies that had a mean. So my standard deviation is 21. Oh, I said that wrong. My standard error of the mean is my standard deviation divided by the square root of n. Sorry. So to figure out my standard error of the mean, I'm going to take the 21, my standard deviation, my population standard deviation, and divide it by the square root. Here's on my calculator. Square root of 11. So this gives me the standard error of the mean. This is the number that I need to type into my standard deviation on my normal calculator. So let's go to a couple decimal places. I'm going to go to 6.3317. Sounds good. And it still said less than 227. Now the idea is that our probability is going to become less. This one has a 0.1032. So let's verify that that's correct first. 0.1032. And it's correct. So I want you to think about this. And these, I think, you could keep going with that idea, 36 pregnancies and move on. But here's the idea. Do you know of one person, like if we talk about the normal gestation period for a human, is roughly 9 months. I think that's 280 days, right? So 280 days. Do you know of someone that's given birth 3 weeks early, so 21 days earlier? And a lot of us have. That's not uncommon. But if we took a sample of like 30 women and found out that the average gestation period for those 30 women was 21 days less, we would think something's going on here. We would think that there's something in the water, they live underneath power lines, or they live near a nuclear plant. There's something going on. So our probability of that happening is going to be less. Same thing that happened here. So one person, 227, with the mean of 235, 35% of the time it's going to be 227 or less. If the average was 227 and had 11 people, that gets a little bit more unlikely. And so it's 10% of the population of groups of 11 would have that. So again, the standard error of the mean, this idea in section 1, that's what it's referring to. All right. So if I have more than one person that I'm sampling, I have to take my standard deviation and divide it by the square root of n. That's what we did over here. So hope this helps. right now, as we speak, y'all are taking your midterm and hopefully doing awesome on it. But I hope you're having a good day, and I will catch you next time.